So, very good morning, students. Again, we can continue our topic of gravitation of the physics, that is the Newton's law of gravitation. Okay. So now, in the gravitation last point which I have explained to you, the different types of forces. Okay, the difference between mass and weight. Okay, what is gravitation? So then the different forces which I have discussed with you is the first of all gravitational force, electromagnetic force, electrostatic force. Okay, then now nuclear force, strong nuclear force and weak nuclear force. So these are the different types of forces that we have learned. And you know the weakest force in the universe is the gravitational force, and strongest force in the universe is strong nuclear force. Okay, this is how many times it is stronger than that of gravitational. 10 raised to 38 times it is stronger than that of the gravitational force. Okay, that all these things we all learn. And now we can come to the point. So Newton's law of gravitation. Okay, sir, what is the Newton's law of gravitation? What he said about Newton said about the gravitation? According to Newton's, okay, what he said, every particle in the universe attracts to every other particle with the force which is directly proportional to product of their masses and inversely proportional to the square of the distance between the two masses. Okay. So what is the meaning of that statement? Now you see, students, if I will take the 2 point masses, so this is the first mass having m1, and this is the second mass, that is the m2. They are considered to be a point masses. What do you mean point masses? Again I will define to you. The distance between the two masses, separation of the two masses, will be large as compared to their radii. So now if I will take this point masses, means don't consider, so these are the 2 point masses. Okay, because here sun and earth can also be considered as a point mass, because the distance between sun and Mars is very large as compared to their radii. So radius of the earth and radius of the sun as compared to their separation is large. So suppose this is the separation r, we can say like this. So r is separated between that is m1 and m2. Okay. So according to that, Newton, he said that this mass is attracted by this mass is attracted by this mass. There will be always a force of attraction is going on between the any two masses in the universe. But how they are, that means proportionality sign is there. So that force of attraction F is directly proportional to product of their two masses m1 and m2. And this F is also inversely proportional to square of the distance between the two masses, that is the supposed to be r square. R square is the separation of the distance between the two, that means masses. So now if I combine both the statement, then F is directly proportional to m1 m2 upon r square, and we can also say that F is equal to that, if I'll remove the proportionality sign, so that will becomes G into m1 into m2 upon r square. Okay, so that force is called as the Newton's law of gravitational force. Now here, what is that G? That G is called as the constant of proportionality. Actually, this is the gravitational constant, where G is the gravitational constant. Okay, G is the gravitational constant. Okay. Now once you got that G is the gravitational constant, m1, m2, these are the two masses, and r is the separation of the distance between the two particles. Okay. So here in that case, we can also say that this law is also called as universal law of gravitation. Newton's law of gravitation is also called as universal law of gravitation. So why it is called as the universal? Because it can be applicable for any two masses which are, that means that available in the universe. Okay, so that two masses which are separated by some distance, so that force can be exist into that your any two masses in the universe. So therefore it is called as the universal law of gravitation. So that is G is the gravitational constant here. And so what is the value of that G? G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay. So now sir, what will be the that your SI unit of G? So SI unit of G will be can you tell me, F into R square upon M1 into M2. So therefore here F can be measured in Newton, R can be measured in meter square, and M1, M2 is measured in kg. So therefore that is called as kg square. So therefore Newton meter square per kg square. So that will be the SI unit of your, that is the gravitational constant G. CGS unit of G is, can you tell me what will be the CGS unit? Dyne centimeter square per gram square. Okay, so that will be the CGS unit of G. Now once you got that SI unit, CGS unit, so suppose if I want to write down the dimensions of G. So can you tell me what are the dimensions of G, gravitational constant? That dimensions will be the dimensions of force, that is the M1, L1, T raised to minus 2. R will be L square and divided by mass will be kg, that is the M square. Okay, so therefore your formula will becomes M raised to, if I will say M raised to 1 mass into acceleration due to gravity. Force will be M1 L1 T raised to minus 2 L square per kg square. So that will be the M square. So M raised to minus 1. So what will be the dimension formula will becomes M raised to minus 1 L raised to 2 plus 1 3 and T raised to minus 2. So these are the dimensions of that your gravitational constant. Now once you got that law of gravitation, then now some questions which can be asked here in that on that topic. So that these questions will be gravitational force in terms of distance between two different spheres. Okay. So now if I will say, so now there are the two spheres are there which have been separated by the distance r. So that your F will be inversely proportional to r square. Okay, if these are the two different spheres. Okay, gravitational force between two different spheres, having the masses m1 and m2 and separated by the distance r. So then now this force will be inversely proportional to r square. Okay. So now here in that case, if the question is, sir, what is the nature of the graph? If I want to plot the graph of f versus r square or f versus r, what will be the nature of the graph? It will be a rectangular hyperbola. Okay, because this is the inverse variation, whether it is f versus r or f versus r square. So that graph will be always a rectangular hyperbola. But if I have asked you a question, what is the nature of the graph between f and 1 upon r square? Then what will be the nature? It will be a straight line passing through origin, because I will take this is the complete force. So F is inversely proportional to R square but directly proportional to 1 by R square. Okay, so you just remember this is for the two different spheres. But suppose what is the gravitational force in terms of the radius of the sphere of same material? Okay, suppose these two spheres are there and which have been separated by some distance r. Okay, and if I want to find out how that force is related, so then now here in that case, if this force means this, if the two spheres, gravitational force between two similar spheres. Similar sphere, and not only that, similar spheres in terms of the radius of same material. Similar spheres of same material. Same material. Okay. So now, sir, how that gravitational force will be? Suppose this is the first sphere, this is the second sphere. These two spheres have the, say, that means radius is supposed to be, so these are the centers. So therefore, radius of that two spheres is supposed to be r. Okay. And now, so we are always measuring the force of attraction from their centers. So therefore, this answer, that means this will be 2r separation of, that means between the centers of the two spheres will be 2r. So therefore, what will be that force? Force is equal to, so this is the m, this is m. Okay, similar spheres are there. G m into m upon, here that will be 2r square. So that will be 2r square. Okay, so you just remember separation 2r square. So now f is equal to gm square upon 4r square. G into m square upon 4r square. So here in that case, f is inversely proportional to not only r to r square. So that will becomes how much? So that will becomes here 4r square. That will becomes 4r square. Okay. And now, if the material is the same, 4r square, if I would say like this, f is inversely proportional to mr square. And if that material is the same, then we can write down in terms of density. But density is equal to mass upon volume. So mass is equal to density into volume. So therefore, that is equal to density into 4 by 3 pi r cube, volume of the sphere. Okay, so because that means these are the two similar spheres are there. So 4 pi by 3 pi r cube. And if I put this value here, so then this force will becomes F equal to G into rho into 4 by 3, gm square, 4 by 3 pi r cube raised to 2 upon 4r square. Okay, so now what I will do, I will cut that 4 get cancelled. So that is equal to 1 by 3 g rho pi r raised to 3 to the 6, 6 minus 2, that is equal to 4, means 1 by 3 g rho, okay, pi into r raised to 4. Okay, so that will be your relation. So here in that case, so the MCQ is, if these two spheres have been made up of same material and having the radius r, and they separated by the now distance will be 2r. So then that force is directly proportional to r raised to 4. F is directly proportional to r raised to 4. Okay, so that is the another MCQ. Okay, so means if you can consider, so that if this is gravitational force in terms of density of earth, if I will say, if sir, instead of that, if suppose these are the two spheres, but I want to take the density of the sphere. So if I want to write down this equation, sir, then how that equation will be? So that also the next MCQ will be there. Okay, I can rub this now. Okay, I will rub this MCQ, means F is directly proportional to here R raised to 4. Okay, but if suppose here these two masses are not the same, suppose if I will say this is the earth, okay, earth having the mass m, and this is the another body having the mass m, and their centers which have been separated by some distance r. Okay, so now here in that case, so in terms of the density of the earth I want to calculate, so then that force will be F is equal to G m into m by r square. So that will be the your force, where M is the mass of the earth and small m is the mass of the body. This body is always attracted towards the earth. Okay, you remember, and divided by r square. But here in that case, I want to write down this force in terms of density of the earth. Okay, so gravitational force in terms of density of earth. Gravitational force, gravitational force in terms of density of earth, density of earth. Okay, so now students, if I want to write down like this, so then I have to say F is equal to gm by r square into capital M, and then you write down the mass of the earth will be gm upon r square, that is equal to density into volume. एंड व्हाट इज द वॉल्यूम ऑफ द अर्थ? बच्चे लोग कौन बताएगा? क्योंकि वॉल्यूम क्या है? वो दैट इज द स्फीयर, एंड सो देयरफॉर वॉल्यूम ऑफ द स्फीयर इज 4/3 pi r cube. So therefore that will be rho into 4/3 pi r cube. Okay, so now can you tell me what will be that equation? So that will becomes 4/3 g into small m into, so that will be rho, and into pi, and that will be r raised to 3 minus r raised to 2. So therefore that answer will be 4/3 pi, that is into rho into g into r into m. Means F is directly proportional to RE. People are talking about the density. Once you got that this equation, then we want to learn the Newton's law of gravitation in a vector form. Okay, so what will be the vector form? Okay, so that will last point we can finish. Okay, Newton's law.